Okay, we will start the next topic. It is projection of planes. Okay, projection of planes. So from the orthographic projection we have got the projection of points. It's a dimensionless entity. Then we have seen projection of straight line. It is a one-dimensional entity, right? Then projection of plane from a line. We have got, if I extrude a line, if I extrude a point, I will get a line. Okay. If I extrude a straight line, I will get a plane, planar surface. Right. So here, projection of plane surface. So here, any plane you take, it will have a length and breadth. Okay. The plane is a two-dimensional surface, will have a length and breadth, and it will have a negligible thickness. Okay, we assume that it will have a negligible thickness. So you see here, I have a plane. So it has some thickness actually. So, but I am assuming that it has a negligible thickness. It is a plane. It's a triangular plane. It is a plane. Right. So similarly, I have various planes. So I have a hexagonal plane. I can say hexagonal plane with negligible thickness. So this is a circular plane. So I can say this is a circular lamina. So in other way I can say circular lamina, a circular plane. So they have square planes like this, right? The plane, you make a note, the plane will have, the planar surface will have a length and breadth. Planar surface will have a length and breadth, and next plane in the first quadrant. In the first quadrant. So I told from straight 10, so all the planes or solids will be kept in the first quadrant. You are asked to draw the projections as per the first angle projection. If I am keeping the solids objects on the first quadrant, that will be a first angle projection. Right. So positions of the plane, planar surface in the first quadrant. So first position, if I consider it is a plane, you can say a perpendicular plane. So a square plane I have. So how it is with respect to the horizontal plane and a vertical plane? Yes. Parallel to the horizontal plane and perpendicular to the vertical plane. So this is one orientation I have. So broadly I can classify the planes as perpendicular planes and planes is perpendicular to one plane, then it is a perpendicular plane. If it is not perpendicular, if it is inclined and perpendicular, it is plane is inclined to one plane and it is perpendicular. You have an oblique plane. Okay, oblique plane in the sense the plane will be inclined to both the reference plane. If the plane is inclined to HP and if the plane is inclined to VP, then I can say it is an oblique plane. So the plane is inclined to both the reference planes. Then it is termed as oblique planes. Okay, so remember. Then we will have the various positions. The first position, as told, the plane is parallel to HP and perpendicular to VP plane. Not the reference plane. It is a plane surface. Planar surface is parallel to HP and perpendicular to VP. Right. In this orientation, I am not going to give problems. Okay. So you see here. So in this orientation, where I will obtain the true shape of the plane. True shape, square, true shape on the top view. Wherever it is parallel, I will obtain the true shape. Similar to a straight line. Straight line, if it is parallel to any one of the reference plane, on that plane I will obtain the true length. Similarly, if it is parallel to horizontal, wherever which plane, reference plane, which plane it is parallel, on that plane I will obtain the true shape of the plane. So the plane problems you have to proceed by drawing the true shape of the plane first of all. So whatever orientation, you will be trying to draw the true shape of the plane first of all. From there you will be proceeding. So now this plane is parallel to HP. So I have to draw the true shape on HP and the line will be seen on front view. Why I am seeing as a line in the front view? Negligible. Why it is seen as a line? Since it is perpendicular to the plane, reference plane, since it is perpendicular to the reference plane, I can see a line on the reference, line as a view on the reference plane. Right. So you can be clear with this. If a plane is parallel to any one of the reference plane, I will obtain the true shape as the view on that plane. If the plane is perpendicular to any one of the reference plane, I will obtain a straight line as a view on that plane. Right. Make a note. So plane is parallel to one of the reference plane, and then the true shape is obtained as a view on that plane. View on the plane. Right? Is it clear? Right. Then second note, if a plane is perpendicular to a reference plane, planar plane means planar surface is perpendicular to a reference plane, then a straight line is obtained as a view on that reference plane. A straight line is obtained as a view on that reference plane. Now you tell me, so without problem, so this is a rectangle of, see here, this is a rectangle of side 40 mm, right? And it is parallel to horizontal plane and it is perpendicular to the vertical plane. How I can draw the projection? Draw the front view and top view. How I can draw the projection for this?
Top view will be the same as the
true length on the horizontal plane, and front view will be seen as a line. So what I told you, draw the true shape first of all as per for the projection of plane concern. So you know this, for this orientation the true shape will be obtained on horizontal plane, that is nothing but the top view. So I can draw a reference line. So see here, make a note in your notebook. I can draw a reference line. This is my square, VB, HP. So this distance in front of distance or nothing. The true shape of the square I am drawing, since I know this orientation is like this. Like this, right? So this is the true shape. The size is 40. The side is 40. I am drawing. This side is 40. So as per the problem, it is 40. Right. Now the plane has 4 corners. So this is a top view. Top view notations are without dash. So you have to give the notations. So you give the notations from here. Okay, for plane solid, give the notations from the left corner to the anti-clockwise manner. Right. So this is going to be my A. This is going to be my B, C, D. This is the way you have to give your notations. Okay. Starting from the left bottom corner, you give the notations in an anti-clockwise manner. Now you know this projection of the front view. Okay, this is the top view. Because it is parallel, the true shape will be obtained as a view. Top view in my horizontal plane line. Then the front view will be a straight line we told. So the above distance will be given in the problem. Right. The front view will be a straight line. Right. So straight line, this distances will be given, above distances. So straight line, how it will be? The front will be seen as a straight line parallel to the reference line. So I can see the plate's front view. The plate's front view will be seen as a straight line. Since it is perpendicular to the plane, it will be seen as a straight line. So now you have to give the notations for the front views. So I have my A here. Right. I have my A here. So in the same order you give A is here. Right. B is here. Then there itself I have C. Right. Then there itself I have here D. Okay. So I have D. So what is this? Is it small letter? This is the front view notations. We have to note it with dash. So see here, this is with dash. Right. Now, still it is not over. What is missing? Which one is hidden, which one is visible? As for this is the thing. A I have marked here A, B, C, D. Right. For you which is visible, A, B is visible, C, D is hidden. So that is in a simple way to draw put the hidden details. Okay, to mark the hidden details in the front view, you have to look the top view from the bottom. I can look the top view from the bottom. While looking from the bottom, I can see A and B. I cannot see C and D. So C and D is hidden. So that C and D, I can put it inside bracket. I cannot put it inside bracket. So this is how you have to finish the problem. Right. Without problem I have given. So whatever data should be given in the problem, the plane is 40 mm like this. Right. Then you see this one side of the plane is how it is. One side of the plane is how it is. As per I have drawn, it is parallel. One side is parallel. Otherwise, one side is how it is. Other side, it is perpendicular. That is given in the problem. Right. Then, what will be this distance? This distance is not given. I have taken arbitrarily. I have taken. That is nothing but my in front of distance. It will be given a edge of a plate is parallel and it is 10 mm or 20 mm in front of. Say, this in front of distance will be given in your problem. So what is this distance? Oh, this distance. Okay. What is? It is some distance above. So this is the above distance will be given in second orientation. You make parallel to VP, perpendicular to HP. What is this orientation? It is parallel to VP and perpendicular to HP. Right. Again a square plate I am taking. You see the square plate. How I am going to keep? I am going to keep like this. So you see, I am going to keep like this. So one edge I am going to keep, it is inclined, but it is parallel. The plate as such it is parallel to VP, and as such it is perpendicular to HP. Right. So now in this orientation, where I will obtain the true shape? Vertical plane. That is front view I will obtain the true shape. Top view will be a straight line. Will be a straight line parallel to the reference line. Right? Is it clear? So you take a problem here. A square plate of side 40 mm. As one of its corner 20 mm above HP and 20 mm above HP and 25 mm in front of BP. 25 mm in front of BP, full stop. The edge adjacent to the corner, the edge adjacent to the corner is 30 degree inclined to HP. 30 degree inclined to HP, full stop. Draw the projections of the plate if the plate is parallel to VP and perpendicular to HP. The plate is parallel to VP and perpendicular to HP. You see, it is parallel. See here, it is parallel. How I am going to proceed? So you know, it is parallel to VP. So front view will have the true shape. As I told you, proceed the problem with drawing the true shape as per plane concept. Where I will have the true shape here in the front view. Right. So I can move to the front view. I can draw the true shape. You see the reference line. Reference line like this. Right. What is given in the problem? As per the problem, one corner. This is a corner. So corner A. I can mark this corner A. It is 20 mm above and 25 mm in front of. What I can mark it? A dash A. I can mark it, right? This is 20. This is 20. This is 20. This is 25. This is 20. This is 25. This is 25. So what else it is given? The edge adjacent to that corner, it is 30 degree incline. Either this is 30 degree incline, what would be this? This is 60 degree. So this is, I am keeping this as, it is 30 degree incline. So I am drawing a square of 40 mm, keeping this edge is 30 degree incline. What is this inclination? This is 30 degree. This inclination is 30 degree. Right. So then I can proceed for the drawing the true shape of the square. True shape of the square, the size is 40. Right. If size is 40, I can draw the true shape. Size is 40. So how I can draw? I have to draw perpendicular to this. Now I can draw the true shape. So this is the plane I have. This is 40. Side 40. So now I have to mark the notation. How I can mark the notation here? Already I have A. In an anti-clockwise manner I told you to give the notation. So this is A dash. This will be my B dash. This is C dash. This is D dash. Right. Now what will be my top view? Since the plane is perpendicular to horizontal plane, the top view will be a straight line. So the projection will be to the maximum of this. The straight line will be to the maximum of this. So I can draw the projection here. Projector here. Where it meets here. Similarly here. So this is going to be my top view. So the top view is this. Okay. So the various corners I can mark it. So this is my corner A. Where I have B. This is B. This is C. This is D. Now, which is hidden, which is visible here? In this, so how I have to look at it? I have to look from the top. So these three corners will be visible for me. D, C, B. Which is hidden? A is hidden. So A will be hidden here. So I can put it inside. Right. Is it clear? Then the third one. Plane is perpendicular to both HP and VP. What is this orientation? We have a plane like this. So it is perpendicular to VP and it is perpendicular to HP. So where I will obtain my true shape in this orientation? True shape will be right side. Either front view, so it is perpendicular to HP and it is perpendicular to VP. As per you know, wherever it is perpendicular, I will obtain a straight line as a view. Okay, both the views I will obtain a straight line. But in both front view and top view, I don't obtain the true shape. Where I will obtain the true shape? Wherever it is parallel, to which reference plane it is parallel. So I will have an auxiliary plane. Okay, so on auxiliary plane I will get my side views. Okay, so it is parallel to the axillary plane. The plane is parallel to the axillary plane. So I will obtain the true shape on the axillary plane. That is, the axillary plane will hold the side view. Right, either left side view or right side view. So you have to start this problem. Okay, by drawing the true shape in this side view. You have to draw the true shape on the side view. And from there I have to draw my front view and top view. Right. So take a problem. A square plate of side 40 mm has a corner A 20 mm above HP and 25 mm in front of VP. So the edge adjacent to the corner A is equally inclined to the horizontal plane. So it is like this. It is like this. The corner A. This corner is A. It is this much distance above and this much distance in front of. And the edge adjacent to that is both are equally inclined to the horizontal plane. Right? Equally inclined in the sense it is 45 degree. It is 45 degree. Right? To draw the projections of the plates, if the plate is perpendicular to both HP and V. Now I can draw it. Draw the reference line X, Y. So I am going to draw the step here. VP, HP. Right. So I am going to draw the side view. Side view will be on the left side, will be on the right side. So right side view will hold the true shape of that plate. So the one end is A and A, it is 25 mm. Okay, have it that end A is, instead of 25, I can correct this is in front of distance, you can have it as 40 mm. In front of distance, you have it as 40 mm. So this distance, in front of distance is 40. This distance above distance is 25. Right. So from here I can draw a true shape of the square plane. How it is, the adjacent side to this corner is equally inclined. Okay, 45 degree will be inclined. So I can draw a 45 degree. So this is my end A. Notation is as per side view I told. What should be the notation you have to give? Small letter with. So front view with the dash, top view without dash, side view I can have suffix 1, right? So I can have A1. This is so in a clockwise manner. Anti-clockwise this is B1, C1, B1, right? So this goes as one side. Now, how I can get the front view and top view? If you know the front view and top view is going to be, since it is perpendicular to VP and HP, the front view and top view is going to be a straight line. Going to be a straight line. That straight line, how I can obtain it? So from the side view, from orthographic projection I told, there will be relation between the front view and top view, and front view and side view, there will be a relation. Okay, how I can relate that? So if I open the axillary plane and the horizontal plane, what will happen? I will have this is an axillary plane, this is an horizontal plane. If I close it, I will have a box. If I open this, so with reference to this is my vertical plane, this is my horizontal plane. So this I am opening it, closing it, this I am closing it. So with a 45 degree line, this top view and the side view will be linked. With the 45 degree line, the top view details and the side view details are linked. Similarly, the front view and side view details are such it is linked. Right? It is inline horizontal. Front view and top view it is inclined vertical. Side view and top view it is linked with a 45 degree line. Right? So how I can draw the front view from the side view? It is, the front view will be inline horizontally, so I can draw projectors from all the corners straight. So what should be your front view? What should be your front view? It will be a straight line. So my final front view will be a straight line of this length. The final front view will be a straight line not equal to 40. Not equal to 40. To this distance. Okay, to this distance it is the front view length I will have. Right. So to this distance I will have my top view length. So the front view and top view will be inline vertically. So on the same projector I will have my top view. Right. On the same projector I will have my top view. So these details I have to get it from the side view. So I can draw a projector from the side view to the 45-degree line. So that details can be horizontally transferred to the projector. So this detail it is nothing but my final front view length. Is it clear? So the front side views and the top view get linked with a 45-degree line. Okay. So these rotations, this is my A, this is B, this is C, I will have D here. Again, here I will have, these are all with dash, A dash, the front view. Here I will have my A, B, then C I have again here, D is here. So these are all without dash, this is top view. Right. So which one will be inside bracket, which one will outside bracket, that you have to define. See here, this side view, this front view, from the side view I can see, from the side view, this is the way I am looking for front view. So what is corner is hidden, D1, so D1 is hidden, D is hidden. So for the top view, I have to look at the side view from the top, which is the corner is hidden here. A is hidden. Right. The next case, you see here, this is a plane like this. Right. The plane surface is inclined to horizontal plane. It is perpendicular to vertical plane. So another case, plane inclined to horizontal plane. Okay, this theta perpendicular to vertical plane. So this is a case, the plane is perpendicular to the vertical plane and it is inclined to the horizontal plane. So since it is, you see here, so as per projection of plane concern, you have to start with the true shape, drawing the true shape. Where I will obtain the true shape in this orientation, with which view I will obtain the true shape. So front view will be a line, that is not a true shape. Top view, since it is inclined, I cannot obtain the true shape in the top view. If it is parallel, I will obtain the true shape. It is inclined, I don't obtain the true shape of the square on the top view. Side view, it is not parallel to the axillary plane also. If it is like this, it is parallel to the axillary plane. Now it is inclined to the axillary plane also. Side view also, I won't obtain true shape. Then how I can proceed this? So what I can do is, this kind of problem, you can see here, I can assume in the first step, okay, I can solve this kind of plane inclined to one plane, I can solve it in two steps. The first step I can assume the plane parallel to the horizontal plane. So since the plane is inclined to the horizontal plane, the surface of the plane is inclined to the horizontal plane, I am going to make it assume the surface of the plane is parallel to the horizontal plane. So if I draw, it is parallel to the horizontal plane, what will be my, where I can draw the true shape? I can draw the true shape on horizontal plane. I will get a front view as a straight line, that front view length is same. So if I tilt like this to the 30-degree inclination, I will have the same front view length. So in the first step, in the assumption step, I am making it to parallel to horizontal plane, I will obtain a length. That same front view length is going to be my final front view length, even though it is tilted. after it is tilted, what is the front view of the straight line, what is the length of the front view of the straight line, it is going to be same after tilting. So this kind of plane inclined to one of the reference plane, I can solve it in two steps. I can make the plane first of all parallel to the reference plane to which it is inclined. To which it is inclined, I can make parallel to that. Then in the second step, I can reproduce the same front view in this first assumption of what I have. I'm obtaining the front view that I can reproduce in the second step. So that is going to be the final front view, and from the second step I can go for the final top view. So this kind of problems I will be approaching in two steps. The first step is the simple position step. Okay, so I will be assuming the plane is parallel to the plane at which it is inclined. Right. Then I can draw the true shape, I can project the front view as like your first problem. Right. Then in the second step I can tilt the front view, I can get the final top view. Right, is it clear? So where I will obtain the true inclination in this case, true inclination of this plane. True inclination, it is the plane is 30 degree inclined to horizontal plane. The true inclination I will obtain it on the vertical plane. Right, where it is perpendicular, I will obtain the true inclination on where it is perpendicular. Right. So you take a problem in the what I will be doing, first I will be making it to parallel, I will get the true shape and the front view. That front view I will tilt it to the 30-degree angle. Okay, then I will obtain this top view. Right, because front view and top view is linked. Right, so 2 steps I will be solving. Take a problem here. Hexagonal plate of side 30 mm is resting on the horizontal plane with one of its edges such that the surface of the plate is 30-degree inclined to HP. Full stop. Draw the elevation and plan of the plate. Given data here, the hexagon is given of size 30 mm. Right. Second data given is it is resting with the edge. It is resting with the edge on HP. Right. It is resting on. It is resting with the edge. With the edge. Okay. These are all essential things you have to note it down in projection of plane problems. Right. And the surface is inclined. Surface inclination. Surface is inclined. How much is 30 degree? It is nothing but what? Theta. Right. Surface is inclined to 30 degree. It is nothing but theta. You are asked to draw the projection. The surface is inclined to 30 degree to horizontal plane, and it is perpendicular to VP. How the surface work? It is 30 degree inclined to HP and the surface is perpendicular to VP. Okay. And the surface is perpendicular to VP. These are all the things we have to note it down for a problem. Okay. How I can solve it? As I told, since the surface is inclined to HP, I can make the surface is parallel to HP. Right. Surface is parallel to HP in the sense where I will get my true shape of the hexagon. Surface is parallel to HP means where I will get the true shape. Since it is parallel to HP, this is HP. I will have my true shape. So the true shape of the hexagon, I can draw it. Okay, hexagon, how I can draw it? I can draw it in two orientation. See here, I can draw the hexagon in two orientation. Make a note, this is very essential. If a hexagon, any problem it is essential. If the hexagon is resting with the edge, if a hexagon is resting with the edge, resting with the edge, resting with the edge, I can draw it. I can draw the hexagon keeping an edge to the right side. Keeping an edge to the right or left side. Something like this orientation I can draw it. Right. If the hexagon is resting with a corner, so which orientation I have to draw it? And another orientation I have to draw it. The orientation will be like this. Right. Two orientation. If the hexagon is resting with the edge, I have to draw it like this. If a hexagon is resting with a corner, I have to draw it like this. Right. Otherwise, you will be end up with the wrong front view and top view. Right. So similarly, if this is for hexagon. If it is pentagon, how you can draw it? If it is resting with the edge or corner, both are going to be same. I can draw it like this. I can draw it in this orientation. So yeah, edge I can keep it vertical. So I can draw the pentagon like this. If it is resting with the edge or corner, both things, I can draw the pentagon like this. Is it clear? So for pentagon, if it is resting with the corner or the edge, the true shape I have to draw it like this. If it is resting with the corner or resting with the edge, okay, I can draw it like this. For a hexagon, if it is resting with the edge, You have to draw it like this. If it is resting with a corner, you have to draw it like this. Okay, pentagon it varies, hexagon it varies, pentagon you can have it any. By having it, you should not draw the pentagon like this. Pentagon on edge keeping like this. You should not draw it like this. This is the wrong one. Is it clear? This is the wrong one. As for projection of plane concern, if you are resting with the edge, you have to draw it. For hexagon, resting with corner, you have to draw it like this. For pentagon, it is same. Keeping a edge vertical. Keeping a edge vertical, right? So now, make a note in your notebook. Very essential, right? Now, as per the problem, how it is resting with a edge. So I can draw the hexagon in this orientation. The edge I can keep it vertical. Right. So in this orientation I can draw my true shape. So where I have to draw the true shape? On from HP. Where it is inclined, it is going to be parallel to that. So horizontal plane. In which orientation it is resting with the edge? So it is a hexagon. So I have to draw the hexagon. Hexagon, how I can draw it? I have to draw a circle and I have to inside I have to draw the hexagon. Quickly I have to draw that. So actually you can construct it by a circle of radius equal to the side 30 mm. So inside I can construct. So if I want a vertical edge like this, I have to divide this circle vertically. Okay, in another orientation if I want, I have to divide this circle horizontally. Right. This orientation I have to draw a circle, I have to divide the circle vertically. These two corners I will get. From that corner I can cut 30 mm to the circle. I can end up with a hexagon like this. So you rotate the hexagon. This is a true shape. You rotate the hexagon. This is starting from the left side. This is my A, B, C, D, and F. Right. Now, for this, what will be the projection? It will be a straight line. So if a plane is parallel to one plane and perpendicular to other plane means I will obtain a straight line. Where I will obtain a straight line here? Where I will obtain a straight line here? Where I have to draw the straight line. So the first step first problem I have drawn here. Is it right for this problem? This is wrong. The above distance was given in the first problem. Now here the plane, you see this is a hexagon plane. Hexagon plane, it is resting with the edge on HP. Assume this tool is a horizontal plane. It is resting on HP. What I am going to do, I am first assuming it is making it to parallel. So I am making it to parallel. I am going to lie down the hexagon on the horizontal plane. Okay. So the hexagonal plane is lying on the horizontal plane. So if it is lying on the horizontal plane, it is going to be parallel. I can draw the true shape on the horizontal plane, and the front view will be obtained on where? On the reference line. The front view, you have to mark the front view here as for this problem. So this is going to be my front view. So front view notations are A, B, C, D, F. Right, is it clear? Which one will be hidden, which one is? So to put bracket for the front view, look at the top view from the bottom. I can see ABC, I cannot see FED, right? So D is hidden, E is hidden, F is hidden. So these are all notations with dash, these are all front view notations. Right. Now this is my first step, assumption step. I am assuming it is parallel, it is lying on the horizontal plane and it is perpendicular to the vertical plane. So I have drawn this. What is the problem actually? It is inclined. It is resting on the horizontal plane with the edge and the surface is inclined to 30 degree. Right. So now this is going to be my final front view. Even though the surface is inclined, the front view will be a straight line like this. Okay. That front view I have got it. That front view I have got it here. This is going to be my front view length. This is going to be my front view length. So the front view length I have got it. This front view length I can tilt it to what angle? 30 degrees. So I can measure this. I can reproduce this front view to 30 degree. So that is going to be my final front view. So I can mark a location here. So where on the reference line I am marking it. So on the reference line, which edge I have to keep it? AF. AF is nothing but what? It is an edge. You see here, AF is nothing but an edge. Okay, that edge, it is going to be resting on the ground. That is A dash, F dash. I am marking it on the reference line. Right, on the reference line. Then measuring 30 degree. So this is 30 degree theta. 30 degree. I have to reproduce this front view length on this inclination. How I can reproduce this? I have to measure this. I have to measure this distance and I have to measure this distance. I have to transfer it here. I have to measure this. Right. So this is going to be my B dash, E dash. This is going to be my C dash, D dash. Right. So this is going to be my final front view. You got the next final front view. So how I can end up my final top view? Anybody? How I can draw the final top view? By drawing projectors from the front view and extending horizontal projectors from the previous top view, I can get a final top view. Right. So how I can draw it? I can draw projectors, vertical projectors from this final front view from all the corners. I'm drawing horizontal projectors from the previous top view. So A and C will coincide. So F and D will coincide. Right. Now using this I can mark carefully how to mark. Where I have A here, A is here. So this is my A. So this from A, what is the projector from the previous top view? What is the vertical projector from front to A? So I will get it into section again, that is A. So B will be here, B to B, it meets here, B, C, D. This is my E. This is F. By connecting this ABCD with an order, it will be a hexagon top view. So this top view, see, it is not a true hexagon. It is a apparent shape. It is an apparent shape. It is not a true hexagon, it is an apparent shape having. So this is a true hexagon. This is an apparent shape. Since this is how I have to draw the final front view and top view as for plane inclined to one plane. So I have to dimension the data. So what is the given data? 30 mm of the hexagon side. This is 30. I have to dimension it. This is 30. Angle is 30 degree. If the same problem, if it is in a hexagon resting with a corner, means how I have to draw it here. I have to tilt it in another orientation. So if I draw the projection, I will have the corner on the left side. So two extremes I will have a corner. That corner I have to mark it here. Right. Continue the projection of planes. Right. Projection of planes. The various positions we have seen. In the first quadrant. Right. Last we have seen plane parallel to HP and perpendicular to BP. Okay, wherever the plane is parallel, I can see the same shape, true shape view. Right. And wherever the plane is perpendicular, I can see a straight line as a view. Right, on that plane. Similarly, the second orientation we have seen, the plane is parallel to VP and perpendicular to HP. Right. Since it is parallel to VP, I can see a true shape of this plane. as a front view, and since it is perpendicular to HP, I can see a line on the top view, right? Then this orientation we have seen line. So then another orientation, plane is perpendicular to both VP and HP. So if it is perpendicular to both, then I can see the true shape only on the axillary plane. Okay, it is parallel to the axillary plane. So the side view will give me the true shape. Right, I have to draw the front view and top view. By drawing the true shape in the side view, then from the side view I have to get the front view and top view. Right. Then this inclination we have seen. So this orientation, that is, plane is inclined to HP and perpendicular to VP. Right. The inclination, the surface of the plane is inclined to the horizontal plane. Okay. So in this orientation, I cannot attain true shape in any of the plane, whether vertical plane, horizontal plane, or axillary plane, right? So to draw the projections for this orientation, we have to draw it in two steps. Okay, first of all, we have to assume wherever it is inclined, so you have to make it parallel to that plane. So I can see the true shape and a front view. That front view will be a straight line. That is the final front view. Okay. Front view length I will obtain in this first assumption. Then I will obtain the front view, right? Then that front view will be tilted to the orientation, to this orientation. Okay, what is it is inclined to the horizontal plane. That true inclination I have to tilt the front view. Okay. Then that is going to be my final top view, so final front view. Then the final top view will be obtained by projecting this final front view and get the projectors from the previous top view, right? So I will end up with the final top, right? We will go to another case. What is this inclination? Suppose the plane is like this, right? The plane is, surface of the plane is inclined to which plane? Vertical plane. Surface of the plane is inclined to vertical plane, right? And it is perpendicular to which plane? Horizontal plane. The surface of the plate is perpendicular to horizontal plane and the surface is inclined to the vertical plane. If you take that case, the surface of the plane inclined to VP and perpendicular to HP. A pentagonal plate of side 30 mm is resting on the vertical plane with one of its corners, resting on corner. On V plane. One of its corner such that the surface of the plane is 40 degree inclined to VP. 40 degree inclined to VP, right? And perpendicular to HP. Full stop. Draw the front view and top view of the plane. As I told in the last class, you look for right like this. It is a pentagon. Side is 30 mm, right? And it is resting on what? Resting on a corner on HP and it is inclined 40 degrees. Now it is a pentagon, actually hexagon, it is a pentagon plane, it is resting with a corner on VP, right? It is resting with a corner on VP and the surface is inclined 40 degrees, right? So in this orientation also I cannot obtain true shape in any of my plane, right? So what I have to do? I have to make it aligned to vertical plane, right? That is the first question. I can see the true shape and I can get the final top view length, right? So after that I have to tilt it. The top view length has to be tilted to 40 degrees. Then I can obtain my final front view. So the first assumption I am making it to parallel so that since it is resting on BP and I can see the front view true shape on BP, where I have to draw the true shape for this. On the vertical plane, since it is inclined to vertical plane, I am making it to align on the vertical plane. So this is going to be my vertical plane, okay, above the reference. That is nothing but front view. There I have to draw my true shape. So I have two orientation given as for hexagon. Here for pentagon, there is a single orientation even though it is resting with corner or even though it is resting with edge. So how I have to draw the true shape? Just draw a pentagon, draw a line, draw a side vertical. This is 30 mm. Okay, this way I can draw my pentagon. So you have to give the notation for from the left bottom corner in an anti-clockwise manner. You give the notation. So this is my A, B, A dash. Okay, it's front view notation. B dash, C dash. So this side of the pentagon is 30. You have to dimension that. Then I can get the projection. Since it is resting on BP, the projection will be obtained on which location? The top view, final top, the top view where I have to draw it. Top view, the plate is now it is resting on the vertical plane like this. Okay, where I will obtain the top view for this? Reference line. Okay. So on the reference line, I will have my top view. Okay, this is going to be my top view location of the corner. Okay, this is my A, B, right. So you have to put bracket immediately. You have to, the hidden corners. You have to put the brackets. Okay, which is hidden? AB is hidden. Okay, to put bracket for the top, I have to look at from the top. Okay, AB is hidden. So A and B is hidden. Right. Then what I have to do? I have to tilt this. This is going to be the final top view, and this I have to tilt it to 40 degree. 40 degree. Now your thing is which one I have to keep it here. Okay, both. Which? Either it is resting with corner or resting with edge. It is resting with corner. Okay, the corner has to, you have to mark it on the reference line. Okay, so which is the corner I have here? I have C. Corner is C. Okay, that C I have to mark it. Okay, so depends upon the problem. If it is resting with the edge, so I have to keep AE here. Right, then I have to redraw this, reproduce this top view, right? Here, since it is resting with the corner, it is an important one, you should not make mistake, okay? So here it is resting with corner, the C I have to mark it, okay? The C is the, then it is inclined 40 degree, so I can tilt it 40 degree. Tilt it to 40 degree. So this is 40 degree, you have to measure this and you have to reproduce, okay? What is this distance? I have to transfer this. Right. So this is my A, E, this is B, D. This is going to be my final top view. Right. This is my final top view. So this angle is inclined as 40 degree. Right. Then the final front view I have to obtain is by projecting this, extending the final top view vertically, draw project. Right. Then drawing projector from the previous front view. Okay, from the previous front view, you have to draw projector, horizontal projector. See, now I can mark the corners. Okay, A here I have. So where I have A here? Here I have A. Right. So A to A, where it meets that projectors, that is going to be my A dash. So B to B I have here, and this is going to be my B, C. D to D I have, this is D. E I have here. Right. So if I join this is my final front view. Right. The next orientation is surface inclined to both HP and VP. A pentagonal plane of side 30 mm. Again the same pentagon, side is same. It's resting to the corner on VP such that the edge opposite to the resting corner. The edge opposite to the resting corner is 30 degree inclined to HP. Stop. Draw the projections of the plane. If the surface of the plane is 40 degree inclined to VP, you now resting on corner, right, on VP, resting on corner on VP, opposite, edge opposite to the corner, edge opposite to the corner, alpha is equal to 30 degree. Then one more thing is the one, this is the edge opposite to the resting corner, right? Another one, another inclination is given. Inclined to VP. This is 30 degree, 40 degree, 40 degree to VP. Then I have an inclination, that is the surface inclination. You make a note, that is given as surface inclination. Surface inclination, that is phi, is 40 degree. Right. So the problem you have to carefully hint it like this. So if you are reading as such in a question paper, you get confused. List out the problem, whatever data is given. Okay. It is pentagon 30 mm and it is resting with your corner, that is important. Then it is edge opposite to the resting corner is 30 degree inclined to HP. Right. That is inclined to HP, that is alpha. Right. Then surface inclination is phi, it's 40 degree. So you see, here I have to solve it in 3 steps. Okay, it is both way inclined. The first step you have to draw the true shape. Then I have to take the inclination of the surface inclination in the second step. Then in the third step I will be using the apparent inclination, that is alpha or beta will be given in the problem, right? Now, so which one I have to use it immediately? So how I have to draw first of all the true shape for this problem. So you see here, suppose this is a plate, it is resting. Okay. So edge opposite, okay, it is resting with the corner opposite, I will have edge or pentagon, right? So that, how it is inclined, okay, that I will have a top view for this, okay, in this orientation, where the surface is inclined here, the surface is inclined to VP, right? First of all, I have to make it parallel to VP, right? I will get a projection, okay, that then I have to build for the surface inclination up to get it like this, okay, similar to the previous problem, right? Then What is given? The edge opposite to the resting corner.
C.
What is this? Which is the resting corner here? C. C is the resting corner. Which is the edge opposite to the resting corner here? AE. Great. AE. AE is the edge opposite to the resting corner. That is inclined 30 degree. Okay, to HP. That is alpha. Right. So what I have to do? I have to again reproduce this front view. Okay, reproduce this front view to an tilted manner. Okay, what is the tilt? I have 30 degree. Okay, 30 degree line I have to draw. I have to use this edge on the 30 degree line. Then I have to reproduce the same previous front view. This front view I have to reproduce it again. I will get a final front view. Then according to that I will get another final top view. Right. So here in this orientation I don't obtain a straight line as a view. Why? Why here in the previous problems I had a straight line as a view. Here in this orientation the final front view and final top view will be a shape of a pentagon. Okay. It will be some other shape. Why I will not obtain a straight line? It is not perpendicular. The plane in this case, it is not perpendicular to any of the plane. It is inclined to both the plane. So the plane, if it is inclined like this, okay, let's take, I can see a front view for this. Okay, I can see a top view for this. Okay, some other shape I will have. That shape, front view and top view, you have to get it. Right. So first of all, very first step, how you can proceed is, okay, already I have. Very first step, how you have to proceed it, I have to draw the true shape where the surface is inclined. In which plane the surface is inclined? It is 40 degree. Or another case, so you have to draw the true shape. Draw the true shape on the plane where the surface is inclined. Surface inclined. Or one more thing I can use it. On which plane? Either it is resting with a corner or edge. Okay, on which plane it is resting? On VP, right? On VP it is resting, or where it is resting. Where it is resting, right? Listen good. So because why if you are making mistake in this one very first step, the whole problem is final front view and top view will be right. Instead of drawing the true shape here, if you have drawn the true shape and if you proceed with this problem, so final front view and final top view is the wrong one. Okay, you won't get marked at all. So be careful where to draw the true shape. First of all, in the first step, I have to draw the true shape where the surface is inclined or where the plane is resting. In which plane the plane is resting? It is resting in VP. So I have drawn the true shape here. And if it is a hexagon, in which orientation I have to draw it? Pentagon, you have only one orientation. Okay. Hexagon, if it is resting with a corner, the corner has to come right side. If it is resting with the edge, I have given two orientation. Okay. So depends upon the problem how you have to draw it. Draw the true shape. On which plane you have to draw the true shape, it is very essential, right? So draw the true shape here. You will obtain in the first step you will obtain the top view here as a line. Then I am tilting the top view. In the second step, what you have to use the surface inclination. Surface inclination. Use the surface inclination. Right. So use the surface inclination in the second step. You see the surface inclination was given in the as a long. Finally it is given. The angle, so surface is inclined is 40 degree in your problem. It is given finally. Okay. Immediately the given angle was 30 degree. You should not use that 30 degree. Right. You use the surface inclination in the second step. That is 40 degree. Right. So that 40 degree you tilt it, keeping the resting corner or resting edge on the reference line. So here in this problem also it is resting with a corner. So I am keeping with a corner on reference line and I have tilted to 40 degree. I have got the front view. This is not my final front view and final top view. Previous problem it was a final front view and final top view. So this also should be line. See here, this is as for this problem. This is also the second step. This is not a final front view and final top view. Now, this also it should be line. Now, use the third step, use the apparent inclination. So, what is apparent inclination? Alpha. Apparent, why I am saying it is apparent inclination? Here, this 30 degree, the surface is not 30 degree to HP. Only that edge, this edge is inclined, appears to be inclined to 30 degree. That's why it is apparently. Just I have to reproduce one tilted 30 degree manner, right? So you draw a 30 degree line for this. You draw a 30 degree line. So this 30 degree line. 30 degree. This is my alpha, right? It is on this 30 degree line. I have to keep which one? In this previous step, in which one I have to keep it? This one. I have to redraw it. So which one I have to keep it? AE. AE is the rest edge opposite to the resting corner. Resting corner is the opposite edge is AE. So AE you measure it. So here you measure this AE. How I can reproduce? That is a different issue. You have so many methods to reproduce this. The easy method how we can reproduce this. So you see these projectile lines, you can see it's something like a box. It's a rectangle. Okay, that rectangle first of all I can draw it. So from there I can immediately get the point. Is it clear? So this is nothing but a rectangle. It forms a rectangle. Okay, that rectangle size as you measure it. Right. The rectangle size you measure it. And you draw a rectangle here. So this is one method. Then what is this length? I can measure it. These are all constructions. Right. Now, to get these corners, what I can measure this length also. This one also. This length I can measure it. I can draw a line. Right. Then this locations. Okay. This I have to line projectile lines. This line I can measure it. Right. Now I can mark the corners, various corners. This is one procedure, easier. It will be easy for you quickly. Right. What I can do, where I have to keep my AE on this line. Okay, the edge opposite to the resting corner is nothing but AE. That AE I have to keep it on the slant line, 30 degree line. So AE can keep it here. Right. AE is this. A dash. B dash. Correct. A will be here. So what will be this? B. Corresponding to A. Where I will mark, I have to mark B. Here I will have my B dash. Where I will have my, this is my D dash. Where I will have my A, C. C will be, so I have got 4. C will be exactly middle. Okay. In the middle, where I will mark my. Right. And just I am reproducing in a tilted manner, keeping the resting edge. Okay. This is my final front view. Right. So this I can darken it. be my final print. Another procedure, how I can do it, I can draw, I can mark, I can measure this AE. You see here, another procedure, how I can do it. I can, same thing, I can measure this AE. Okay, AE, I can mark it. So this is going to be my A and E. Then, to get this B corner, how I can get it? What I can do it, A, keeping A as center, what is the distance A to B I can measure it? Okay, from A to B I can measure it, I can using my compass I can cut it. Right, so still it is not, it's just an arm they have got, then how I can end it up? From E to the previous one, E to B, what is the distance? That distance also I have to measure it in compass, E to B. From E to B, that distance I can cut it on the same location. Okay, the intersection will give me what? B. So, I am trying to get the corner B. Right. So, A to B is the distance. I have got the intersection. Okay, that is B. The same way I can get other corners. Okay, same way I can get other corner. So, this way I can redraw it. This is one. So, which one is easier for you? You can follow it. This is easier. Right. Just this rectangle. Okay, inside to that rectangle you try to reproduce the final front view. Right. Either follow this procedure or that. It's up to you. Right. See here. Then I have to go for my final top view. Final top, what I have to do? I have to draw projector, vertical projectors from the final front view. So you draw vertical projectors from the final front view. Is it clear? Listen. Here, I have drawn from all the corners from the final front view. Then you draw the horizontal projector lines from the previous top view. Okay, from the previous top view is there. To draw horizontal projector lines from the previous top view. Now, carefully you have to get your final top view. Final top view, how I can obtain? Top view location, wherever A and A is meeting. Okay, from the project A and A I have here, mark that A. Right. Where I have B, B and B, this is going to be my B. C and C. Yes, C will be here. C is on the reference line, so C is this. Then D and D is this. This is my D. E. E and E. This is carefully you have to mark it. Okay. Carefully you have to place the projector from the corners. Okay. Place the projector and mark the point. Now I can join this. You can join this. Right. This is going to be my final top view. Is it clear? Right. You see here, this is going to be my final top view. This problem. Okay, list of the data, first true shape you have to draw it on where it is resting, then you have to use the surface inclination in the second step, right? In the third step you have to use what you are using, use the apparent inclination, right? Then this is go on to the next problem. Keep it a circular lamina of diameter AB 60 mm. Diameter AB 60 mm. Resting now at circumference point A on HP. It is resting on where? HP. Resting on HP. Such that the diameter AB appears to be inclined 40 degree to VP. 40 degree to VP. Appears to be inclined 40 degree to VP means what is this? It will be an apparent inclination. I will explain. Theta, that is 40 degree. Okay, it appears to be inclined. Right, and it is resting on HP, right? Full stop. Draw the projections of the lamina. If the surface of the lamina is 30 degree inclined to HP, that is theta is 30 degree inclined to HP. Surface of the lamina is 30 degree inclined to HP. Now how I can proceed this problem? Follow the previous one. I have diameter AB, circular plate. See here, the circular plate is resting on HP. So HP in the sense from horizontal plane, it is resting with corner. This is the diameter AB, right? AB it is given. It is resting with circumference point A. Okay, this A is going to rest on the horizontal plane, and the surface of the plate is 30 degree inclined. The surface of the plate is
40 degree.
30 degree inclined. Surface of the plate is 30 degree inclined to HP. So this inclination is nothing but my HP, right? And the diameter AB appears to be inclined 40 degree to VP. Okay, this diameter AB in the top view it is up. It will be like this. You can see this plate AB, diameter AB will be appears to be inclined 40 degree. Even though in this orientation you can see the surface is 30 degree inclined to HP, but the diameter AB what I have drawn mark, that is 40 degree inclined. Right? Is it clear? So straight away you can proceed it. How I have told, you look for the thing for the first step where you have to draw the true shape. Where you have to draw the true shape, you look for the surface inclination. Where it is inclined, the surface is HP. So true shape, the circle you have to draw it on HP. Or where it is resting. So it is resting on HP. Draw the true shape of the circle on HP. That's it, right? A simple one is just draw the true shape on HP. Right. This. How many divisions I have to divide this circle? Okay, first of all, this is going to be my center. Okay, the diameter is 60. Going to be this. Okay, this is my A. Diameter A. In the top view it will be marked with small letter. This is A. This is going to be my B. Right. This is going to be my B. Then I have to divide this circle. I have to divide this circle into 12 equal divisions. Okay. If you have a circle that you have to divide it into 12 equal divisions. So how I can divide in 12 equal divisions, you know. Using your drafter two settings 30, 60 degree I can divide it. Okay, carefully you divide it. So while dividing this circle, look for the error also you add it. Okay. So that error in your drafter you carefully add it. Otherwise it won't match. Okay. So this divide. See here, for pentagon, polygons you have corners. Here I don't have corners, I have infinite corners, right? So I am dividing and getting a finite 12 corners here. Okay, that finite 12 corners I can redraw, from the finite 12 points, I can get my final front view and top view, right? So this is my A, B. So other things I can give it in notations. So in numbers I can notate it if you want. Okay, I can notate it. This is 1, 2, 3, 4. Right. Then where I will obtain my front view. Okay, the front view will be seen as a line in the reference line. See, while projecting this 11 is A and 1 and 10 has to coincide. You need not extend 1 and 10 will coincide while projecting projector. Similarly 5 and 6 will coincide, right? So this is going to be my various points on the circles in the front view, right? So this is my A dash, this is my B dash, Then starting from here, 1 dash, 2 dash, this is 3 dash, 4 dash, this is 5 dash. Then I have 6 dash on the same location, this is B dash. Okay, 6 dash I have on the same location, 6 dash, 7 dash, then 8 dash, then 9 dash, then I have 10 dash here, right? See here, which points in the circles are hidden? And I am looking at it from here. So the other half, top half will be hidden. Okay, 6, 7, 8, 9, 10 is hidden. Right. So this 6, 9, 8, 7, these are all hidden. Right. Then in the second step, what I have to do it? Which inclination I have to use it? Second step, which inclination I have to use it?
Surface inclination.
Surface inclination. What is the surface inclination here? 30 degree. So 30 degree I have to tilt the front view. So 30 degree I can draw a line. 30 degree. So 30 degree. Now which one is it resting with a corner, resting with a circumference point, resting on a circumference point, resting with a point. Point what? Point A or B? Point A. So resting on point A on HB. So here which one is going to be rest? A. Point A is going to rest. Point A is going to rest. So A I can mark it. I can mark it on the reference line. So A dash. Then I have to measure all the way. I have to measure these distances. Then I have to transfer it. I have to reproduce these distances. See here, I have to reproduce the front view point location. Here, 1. So this is my A dash, this is my B dash. Right. This is going to be my second step. Inclination is 30 degree. Right. So this is my 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6, 7 dash, 8 dash. Right. Then I have to draw the projectors from the front view, external. See here, I have redrawn the front view to 30 degree inclination. That is this surface inclination. Okay, the line is seen in the view, then the surface is inclined 30 degree. Okay, that line is tilted to 30 degree. That is the surface is inclined to 30 degree. Now I can get the previous second step top view. Okay, the top view, final top view, the appearance how it will be. This is going to be the top view. So I can draw vertical projectors from this front view and horizontal projectors I can get it from the previous true shape top view, right? So the exact A to A where it means you mark various locations. Right, this is going to 2, 3. This is my B. 6, 7. Now with a smooth curve, okay, you try to get a top view of the circle, okay, that will look like an ellipse, alright. So this try to right. This is the my top view, right? So it looks like an ellipse, okay. So you connect all the circular points. This is the top view. Now, in the third step, what I have to, which angle I have to use it? You see here in the problem. Listen, the diameter AB. Okay, the diameter AB is appears to be inclined. Okay, here the diameter AB is appears to be inclined. AB is to be, listen all of you, listen. AB is appears to be inclined 40 degree to VP. Okay, this inclination is beta, it is inclined to VP. It is given in the problem, right? It is 40 degree inclined to VP. Now where I have to draw that 40 degree line? Okay, on VP I have to draw a 40 degree line. Draw a 40 degree line. So how I can reproduce this previous top view, right? How I can reproduce this previous top view to 40 degree one. Okay, this is going to be 40 degree. How I can reproduce? The one thing, you can see the projectors, okay, see the ellipse top view, it is enclosed with a rectangle, okay, with the projector, okay, it is enclosed with a rectangle, and in between you have the various locations, okay, that rectangles you can draw it, you can measure it and you can draw it, right, points you can mark it, that is one thing. But otherwise, see here, this box procedure, reproducing this, redrawing this, the top view, either you can go for box one, okay, you close it with a box, that box, from the box you can get the final, you can reproduce the top view, right? Here it is more easier. I can use for circles, I can use another procedure. You see here. So which one is going to be on this 40-degree line? First of all, AB. AB appears to be inclined 40 degree. So listen all of you. AB appears to be inclined 40 degree. So this AB, where I have in my top view, this is my AB. You measure this distance AB. Okay, conveniently you mark it on this 40-degree line. So AB. So first of all, you mark this AB. This is my A. This is my B. Then, okay. So without a box, what I can do is either you can use box method or that corner from this corner whatever distance from A and B, whatever distance you have in the previous topic, using that you can get the various points, right? Another one, you see AB, on AB, okay, on AB you see here, I have these locations in the previous top view. Can I mark it in between AB? This. Okay, in between AB I can mark these locations, you see here. Right. In between AB I have marked this projector locations. Okay, vertical projector locations I have marked. Then on that vertical projector, using your drafter, you see this projector is perpendicular to this AB. This projector line are perpendicular to this diameter AB. Okay, in this construction, right? So see here, using your graph, you can fix this to fix your one scale to 40-degree line. The other scale will be perpendicular. Using that, I can draw construction lines perpendicularly. I can draw construction lines perpendicularly. Now what I can do is, how I can mark these points? Okay, from these locations, what is the distance for 10? Listen, from the middle, this line, okay, this locations I have marked already. Okay, from this location, I know the distance of 1. Okay, I can measure it in my compass. Okay, from this to 1, what is the distance? I can measure it in my compass. Okay, I can measure it in my compass. That same location I have in 4, using that I can mark 4 points. Okay, so the same distance will have for 10, the same distance will have for 5, for 6. Okay, so I can mark it, the same distance I can mark it here for 4. Right. So I have got my 1. This is my 10. This is 6. 5. Right. Similarly, this 9 distance I can measure it. Either from the middle to 2 distance I can measure it. The same distance I can, using that I can get other 4 points. Right. So from this to 2. Okay, measure it. These distances I am measuring and reproduce again. Right. So just I am getting these points, I am reproducing this top view here. To reproduce this, as it is I cannot draw it. Okay. So first of all I have to get these points, and the points I have to get, then I have to draw the final top view. Right. See here, I have 1, this is 2, 3, 4, 6, 7, 8. Now listen, the 8 distance to 8 I can measure it. That is nothing but equal to the diameter. So clear? Now in this way I can mark all my connecting this, drawing a smooth curve in this again. Top view, right? Then to get the final front view, what you have to do? From here, from all the points here in the top view, you draw vertical projectors, extend vertical projectors. Then the previous front view, you draw horizontal projector. Wherever you are means, okay, connect it. That is going to be my final front view. In my final front view, see this A projector and this A projector will be on the reference line. Okay, so I have to get my A and A on the reference line. Okay, I will get a front view, final front view, something a different one. Okay, will have my circumference point A on the reference line. Then from the previous top view, you draw horizontal projectors. Previous front view, you extend horizontal projectors. Carefully you see, you extend horizontal projectors and vertical projectors from the points. Okay, this is from the previous front view, and this is from the top view, right? So you mark, get the point. This is from A to A. I can mark A. Then 1 to 1, 2, 3. Carefully get the final front view points. Okay, projector you trace it. Similarly, projector you trace it. You mark that point. Okay, then you join these with a smooth curve. You try to draw it first of all in 2H pencil, then darken it. So first of all, by drawing it, it should be an arc. It is not a then get a smooth curve, otherwise you erase it and do it again, get a smooth curve, then you darken it finally. See here, the point A will be on HP, okay, so that point will be resting on the reference line. So that is 1 dash, 2 dash, 3 dash, then A dash, then 4 dash, 5 dash, 5 dash, then B dash, 6 dash, 7 dash. Right, so this is my final front view and final top. Then what are the given data you have to dimension it? The given data, diameter 30, diameter 60, then angle is given 30, we have dimension. This is 40, we have dimension. So this 40 is nothing but my beta. So this is my theta, right? So it is an apparent inclination beta. See here, This diameter I have to dimension it. Circle diameter either like this I can dimension, or with the from the center